Hey everyone, welcome to InsightsByRish. In today's video, we are going to implement a project of time series forecasting using Profit. Now, Profit is an open source forecasting tool developed by Facebook, which is now Meta. And let me also inform you that Profit only works with univariate data. That is, we can have only a single column here, but not multiple columns. So for this project, I am going to make use of this particular data set of temperature from Kaggle. As you can see, daily minimum temperatures in Melbourne. I will provide the link of this data set in the description box to check that. So coming back to the Google Colab here, I have already loaded that temperature CSV file here in the Google Colab environment. So let's start implementing the project. Now starting with, first we have to install this Profit module. So let me just say here, installing Profit module. So here we have to say pip install fp Profit. Let's run that. So now the model is successfully installed. Let me just clear this output. Now starting with the implementation, the first stage of the project is loading the data. So let me just write here, loading the data. First, here we will import all the necessary libraries that we require as per our requirement whenever necessary. So let me just say here, importing libraries. We will start with importing pandas here. So import pandas as PD. Let's run that. And then we will import the data frame here. So let me just say temp_df. This will be the name of our data frame. And here I will say pd.readcsv. And here I will pass the path of CSV file. So let me just copy it from here and paste it here. Let's run that. After doing this, let's try to check the dimension of this data frame. So let me just say temp_df.shape. So this data frame consists of 3650 rows and just 2 columns. So let me just display it for you using the head method. So as you can see on the screen, we just have a single date column and the daily minimum temperature column. This is the column for which we are going to predict or forecast the temperature values later on while inferencing the model. So up till here, this was the first stage of the project about loading the data. Now let's move further ahead to the second stage of the video, which is data pre-processing. So let me just write your second stage, which is data pre-processing. First, we will start with checking for the null values. So let me just say here, checking null values. And here we will say temp_df.isNA.sum. This will give us the count of null values from every column. Here the count is 0 for both the columns, which means we don't have null values in any of the available columns. The second thing now is to check the data type of the columns. So let me just say here, checking the data types of the columns. So here we will say temp_df.info. So as you can see, both the columns date as well as the minimum temperature have the data type as object. So what we have to do here, firstly we have to convert the data type of date column from object data type to date time data type, and secondly we have to convert the data type of daily minimum temperature column from object data type to float data type. So starting with the first stage, which is converting the data type of date column to date time. So here we already have an inbuilt method in pandas to do so, which is to_date time. We will use that. So let me just say here temp_df, and we'll pass the column for which we want to convert, which is date, and here I will say pandas.to_date time. This is an inbuilt method, and here again we have to pass the column name from the data frame, which is nothing but date column from temperature data frame. Let's run that. After this, we will again check for the data type. Let me again say temp_df.info. So now you can see that the data type of date column has been successfully converted to date time. This was the first part. The second part now is to convert the data type of this minimum temperature column to float. So let me just write here, converting the data type of daily minimum temperature column to float. For that, we'll again say here temp underscore df, then we'll pass the column which is daily minimum temperatures here, and then we have to again write the same thing, which is temp underscore df and then daily minimum temperatures. Then we'll make use of as type method, so as type, which explicitly helps us to convert the data type of a column, and here we will say float. You can give the desired data type. If you want to convert it into int, you can do so, but I will go ahead with the float one. Let's run that. And as you can see, we are facing an error here which says could not convert string to float, which means we are having some unwanted characters in our daily minimum temperature column. Let's try to visualize them. Let me just say here before this cell. So here I will say temperature underscore df, and in that will again say temperature underscore df and the column name which is daily minimum temperature, and we will try to see if we have any data in that column that matches with this, that is question mark 0.2. Let me copy it from here, and here I will say equal to this. Let's run that. So as you can see on the index 565, we have a row where the value of daily minimum temperature column isn't fully numerical, which is something like question mark 0.2. So this is some messy data, or we can say unwanted characters. So first we have to pre-process them. So what we have to do here is we have to only keep the numerical characters in this column, in the column of daily minimum temperatures. We don't want any characters apart from the numerical characters. So let's do that pre-processing here in this particular cell. Let me just say here keeping only numerical characters. So for that, what we are going to do here is we are going to replace any other character apart from numerical to white space. So let me say here temp underscore df, and then I will pass the column name which is daily minimum temperatures, and then here again we will say temperature data frame and again the column name which is daily minimum temperatures, and here we will make use of replace method. So here we will say str.replace. Now what are we replacing? So here we will make use of some regular expressions. So we are replacing any character apart from 0 to 9 with a white space. So let me just say here square bracket, then this raised to arrow, and then 0 to 9. This basically means anything except 0 to 9 or anything apart from 0 to 9, and then dot and then hyphen. After this, here we have to give the character with which we are going to replace. So as I said previously, we are going to replace it with a white space. So I will just give an empty character here, and after that we just have to say here regex is equal to true. This regex stands for regular expression, and we are making use of regular expression library here to replace the unwanted characters with an empty character, and hence we have given the attribute regex is equal to true. Let's run that. And now let's try to visualize the same thing that we saw here. Let me just again display it, and as you can see, now it's not showing us any row that consists of this unwanted character, which means now we don't have any such characters in our data frame, and to be more specific, we don't have any such characters in our daily minimum temperature column. So after that, now you can go ahead for converting the data type to float. So let's run that again, and as you can see, now we didn't got any error. So let me again check for the data types here. Let me just say temp underscore df dot info. So now the column date has been successfully converted to date time data type, and the column daily minimum temperature has been successfully converted to the float data type. Now there is an advantage of using this profit module, and that is while working with ARIMA module or while working with LSTM for time series forecasting, we have to convert this date column to index. we have to make this date column as our index, but we don't have to do that here in the profit module. We just have to give this date column as an input and not as an index. Fine. But there is one rule here, and the rule is that this date column should be renamed to DS. That is this date column. Let me just write the comment here. The compulsion with the profit module is that the date column should be renamed to something called as DS, and the daily minimum temperature or any column apart from the date column that you have here should be renamed to Y. So your date column that you are having in your data frame should be renamed to DS, and apart from the date column, whatever the column you have that actually holds the data should be renamed to Y. Only then the profit module can process your data further. So let's do that. Let's say here renaming the columns. So here we will say temperature underscore df dot rename, and we are renaming the columns here. So let me just say columns is equal to, so the initial name was date and now we are renaming it to DS. Similarly, for the other column, the initial name was daily minimum temperature and now we are renaming it to Y. And then we have to say in place is equal to true in order to make the changes permanent. So let's run that. And now let's try to display the data frame here. As you can see, now the date column has been converted to a new name which is DS, and the daily minimum temperature column has been renamed to Y. And this is what basically the profit module wanted. So after doing this, we are done with the second stage of the video, which was data pre-processing. Now we will move ahead to the third stage, which is model training. So let me just say here the third stage, which is model training. And let's run that. Now in this stage, we will actually load the profit module and we will try to fit it on our data frame. So for that, first we have to import that module. So going back to the initial cell, here we will import it. Here I will say from profit, import profit. And let me also ignore the warnings here because this gives us a lot of unwanted warnings. So let me just ignore them. Let's run that. Now going back to the model training stage, here we will load that profit module. So let me say model is equal to profit. So we are loading this profit module in a variable called as model. You can name it anything. Let's run that. And after this, we will fit our model on this temperature data frame. So let me just say here model.fit, and in this fit method, we will directly pass our data frame, which is temp underscore df. Let's run that. And as you can see, once you get this profit ID, which means the training is successfully completed. And now you are good to go for forecasting. So you might have noticed that the training process is very fast here. You can actually see here that the entire training process just happened in a second. So we'll move ahead to the fourth stage of the video now, which is forecasting for the data. So let me just say here, fourth stage, which is forecasting. Now here we will actually try to predict for some specific period of time, evaluating our model. So let me name this variable as future, and here we will say model dot make future data frame. This is an inbuilt method that we get after working with profit module. What it does is, once you predict for a specific time interval, the results, or we can say the predictions, are directly stored in a data frame format with the help of this make future data frame method. Then in this method, we have to pass the periods. Periods basically mean that for how many time interval or for how many frequency of time you want to make predictions. So 10, which means we want to make predictions for further 10 months or further 10 weeks or further 10 days. Now this depends upon what frequency we are giving here. If we say here D, which means it will make predictions for further 10 days. If we say M, it will make predictions for further 10 months. So we will say here D because in our original data frame, the predictions or the observations for every day and not for every month or week. So we will go ahead with the frequency D. And then here we will say forecast is equal to model.predict. We are predicting it for the future. So future. Let's run that. So after after running that, let me just show you the data frame forecast here. As I said previously, it will directly store the predicted data in the data frame format. So as you can see, this is your data frame where you have the DS, which are your dates, and then you have the trend, then y hat lower, y hat upper. Y hat basically stands for predictions. Then you have trend lower and trend upper. Then you have various parameters here that you can go through. After doing that, now we will actually try to plot this results. So let me just say here plotting. And unlike ARIMA, SARIMA or any other time series forecasting method where we actually plot the results using the matplotlib library, here we don't have to do so. Here we directly get the plot method inbuilt, so we will make use of that method. So here I will say figure is equal to model dot plot, and in this plot method we will pass the forecast data frame. Let's run that. So as you can see, these are your forecasted results. The sky blue portion that you have, like the very light sky blue portion that you have, actually shows the range, that is the maximum range and the minimum range in between which the data can fall. The dark blue line that you have, which you cannot actually see, let me zoom it for you. This dark blue line that you have actually shows the median, or you can say the average of the data falling in that particular range, and these black points are actually your data points. So this was the plotting. After that, you can also plot for various components that you have in your data frame, and for that what you have to do is, here you have to say components is equal to, just a minute, so here you have to say model dot plot underscore components. So this inbuilt method of plot underscore components actually helps you for plotting various components that you have in your forecast data frame. And then we will pass this forecast data frame here, and let's run that. So as you can see, you have got three graphs here. The first one is just showing the general trend throughout the years starting from 1981 up till 1991, that is the trend between 10 years. So the trend was very high in 1981, then it dropped drastically in 1983, and then it again started progressing, where in 1987 it showed a drastic progress, and then it remained somewhat constant up till 1991. So this is a general trend. Secondly, we have weekly trend. So weekly trend is computed by observing the trend for every year, that is what's the weekly trend for every year and every month of every year. So this is the general weekly trend that you get from Sunday up till Saturday. So from Sunday till Wednesday it progresses, it drastically progresses, it goes up, and after Wednesday it again starts falling, and after Thursday it drastically falls. And then you have the yearly trend here. So yearly trend, again it is made after analyzing the yearly data from 1981 up till 1991, and after analyzing the data for all the years, then a generalized trend is made, that is how the trend happens for every year, generalizing it. So starting from the 1st January up till the 1st January of the next year. So the starting January 1 is of the current year, and the next January 1 is of the upcoming year. So as you can see, the yearly trend shows that starting from the 1st January up till July 1, the graph drastically falls down, but after July 1 it drastically goes up, which means it progresses. And this trend clearly shows that an entire year here is divided into two cycles, the first cycle of 6 months and the second cycle of 6 months. In the first cycle of 6 months, the progress is very low, that is the progress actually drops. But in the next 6 months, that is from July 1st to the next January 1, it actually makes progress. And then after reaching January 1, again it starts dropping, and again after July 1 it starts incrementing or progressing. So this is the generalized yearly trend after analyzing the information or the data for the 10 years starting from 1981 up to 1991. So these are all the plots, or you can say graphs, that the Prophet automatically gives you with the help of inbuilt methods. So this was a tutorial for implementing time series forecasting using the Prophet module. That's it for the video. Thanks for watching.